Hey everyone, so today we're going to talk about something that's, well, it's pretty much everywhere, but you probably never think about it. It's this hidden force that's running our entire modern world, silently, in the background. It's powerful, it's essential, and honestly, for most people, it's completely invisible. So, let's pull back the curtain on this incredible technology.
All right, let me ask you a question right off the bat. Think about three things seemingly totally unrelated. You've got your phone charger, right? Then you've got a sleek electric car. And then, way over on the other end of the scale, a gigantic wind turbine out in a field spinning away. What on earth could possibly tie all of those things together?
I mean, they couldn't be more different, could they? But believe it or not, there is a secret ingredient. And that ingredient is something called power electronics. Yep, that's the magic glue, the core technology that makes every single one of them work. Okay, so what is this stuff? What is power electronics? Well, I love this subtitle, The Brains Behind the Brawn. It's a perfect way to think about it. It's the smarts that tell all the heavy-duty electrical muscle what to do.
Okay, so fundamentally, you've got these two completely different worlds of electricity. On one hand, you have the big stuff, the raw, high-voltage power coming out of the wall socket or from the grid. Think of this as the heavy lifter, the brawn. And on the other hand, you've got the delicate, low-voltage world of microchips and digital signals, the brains. Power electronics is the absolutely critical bridge that lets those two worlds talk to each other and, actually work together.
So let's break that down a little more. You see it here, right? The power side, that's the muscle. We're talking high voltage, high current, the real brute force that spins giant motors or powers entire cities. Then you've got the electronic side, that's the brain. Super low voltage, tiny currents, this is where all the thinking happens, with microprocessors and digital logic. And power electronics, that's the nervous system that lets the brain give precise, intelligent commands to the muscle.
So if you want a textbook definition, here it is. But really, it all boils down to two key words: conversion and control. It's all about taking electricity and efficiently changing it from one form to another. Think about it. Your wall socket gives you AC power, but your laptop needs DC. That little brick on your charging cable, that's power electronics doing conversion. Or it's about precisely controlling that power, like telling an industrial motor exactly how fast to spin. And the key is, it does all this using solid-state stuff. No moving parts, just silicon.
And here's maybe the best analogy of all. It's a smart translator. It's bilingual. It speaks the language of raw, brute force power, and it also speaks the delicate, complex language of microchips. Without this translator, they'd just be shouting at each other, getting nothing done.
Okay, that's the theory. But the cool part is, this isn't just theory. This stuff is literally everywhere. I mean, once you start looking for it, you'll see it in almost every part of your life. Let's get into some real-world examples.
And check out the scale we're talking about here. It's just mind-blowing. We're going from a few watts, that's your phone charger, to kilowatts, which is thousands of watts, for big industrial machines. Then we jump to megawatts, millions of watts, for things like the entire power grid. It's the same fundamental technology, just scaled up in these incredible ways. So let's bring it right back home. That little black box charging your laptop right now, that's pure power electronics. You know how your LED lights can dim so smoothly? Yep, that's power electronics too. Even your fancy kitchen gadgets, like an induction stove or a modern microwave, it's all powered by this hidden intelligence. And it's not just in your house. It is totally changing how we get around. An electric car? You're basically driving a sophisticated power electronics computer on wheels. It's what controls the flow of energy from the battery to the motors with insane precision. And those super-fast chargers you see popping up everywhere, you guessed it, power electronics is the hero there too.
Now this is where it gets really, really important for all of us, for the future of the planet. Think about solar panels. They produce DC power, but our homes, our whole grid, runs on AC. So how do you connect the two? You need a power electronic device called an inverter to do that translation. Without it, all our renewable energy goals, they'd be pretty much dead in the water. It is absolutely essential.
So this tech is everywhere now. It's transforming our world. But it had to start somewhere, right? Every revolution has a spark. So let's jump in a time machine and go find the invention that really kicked this whole thing off.
Way back in the early 1900s, they had these things called mercury arc rectifiers. I mean, they were these giant, glowing glass contraptions. Super inefficient, kind of scary looking. They were the dinosaurs of power control. But then came the big one. In the middle of the century, we get the thyristor. This was the game changer. This was the moment everything shifted, and it led directly to the small, fast, super efficient devices we have in everything today. So what was this thing, this thyristor? You might also hear it called an SCR, for silicon-controlled rectifier. And what you need to know is this. It was the very first semiconductor, the first little piece of silicon that could act like a reliable switch for really big amounts of power. This was the spark. This was the start of the entire solid-state revolution in power.
So what made it so special? Well, it came down to its internal structure, this clever 4-layer sandwich of silicon called a PN-PN structure. The genius of this design is that it created what's basically an electronic gate. You could send a tiny little electrical signal to its gate, and bam! It would open the floodgates and let a huge amount of current rush through. And it would stay open. It was a reliable, controllable electronic switch with no moving parts. It absolutely changed everything.
All right, so let's bring it all together. As we look at the big picture, what's the one thing, the key idea you really need to remember from all this?
Okay, 3 big things to lock in. First, power electronics is that smart translator between high-power muscle and low-power brains. Got it? Second, it's the ultimate hidden technology. It's not flashy, but it makes almost every modern gadget possible. And third, the invention of that one device, the thyristor, was the spark that lit the fuse on this whole revolution.
And that really leaves us with a big question to think about, doesn't it? Our world is just getting more and more electric. Think about the insane power demands of AI data centers, or what we'll need to explore space. Power electronics is at the center of all of it. So you have to wonder, what's the next big breakthrough? What's going to be the next thyristor that completely changes the game all over again and shapes the world for the next 50 years?